We're going to continue on with lesson 9.7, similar and congruent figures. And this is still, we are on page 457, and we're going to continue on with number 13. Number 13, we're looking at a problem that talks about photography. And it says you are viewing photographs on a computer screen at a scale of 2 inches to 1 inch. It's asking, are the images on the screen and the actual photographs similar, question mark, congruent, question mark, and then we need to explain. So the question, we want to write down the question. So are the images on the screen and the actual photos similar? Oopsie. Question mark. Are they congruent? Question mark. Okay. So if we're looking at two photographs, and the scale is 2 to 1, so the scale is 2 inches on the actual screen and 1 inch of actual photo. So that's our scale. So are they similar? Well, yes, they are similar because they have, they're basically the same shape, I'm assuming. Are they congruent? Well, no, they're not going to be congruent because the actual one are going to probably be smaller than the ones up on the screen. So no, but now we need to explain why. So the question to why. And our simple answer is that they will have the same shape, but they will be different sizes, So they're similar because they have the same shape, and they're not congruent because they are a different size, and that's why. Number 14, skip a line. We want to decide if the objects are usually similar, congruent, or neither. So these are kind of things in real life, and we want to make some comparisons. So if you were taking a look at number 14, it says the buttons on your shirt. Now sometimes there's some kind of fancy, or people purposefully make the buttons a different size just because they want to make it look a little bit artsy or artistic looking. But most of the time when you have buttons on a shirt, they are congruent. They're all exactly the same size and same shape. Number 15, skip a line, they were talking about earrings. And again, earrings, every once in a while you have earrings that might be a little bit different because the designer did it that way purposefully. But most of the time they want them exactly the same size and same shape. So of course that would make it what? And if you said congruent, you are correct. Number 16, the drink on the billboard and the actual drink. Okay, so if you're driving down the road and you look at a billboard along the side of the road that has like got milk, and that drink compared to the actual glass of milk, is that going to be congruent, similar, or neither one? And if you said similar, you are correct, because again they're the same glass of milk or that kind of thing, but they are definitely different sizes. Number 17, we have a C battery and an A battery. And if you know what an A battery kind of looks like, this is a small skinny one that I have, and a C battery is usually about the same length, but they're usually fatter around the middle. So the proportions are different. This A battery, double A batteries, or the A batteries are usually longer and skinnier, and the C batteries are kind of like the same length, but they're definitely bigger in diameter. So in this case, they're not similar because the C batteries are not long and skinny either, and they're not congruent. They're not exactly the same. So in this case, they are neither. Number 18. we have, we're drawing any triangle, and then we want to draw a triangle with the same measures but different side lengths. We want to know, are they similar, congruent, or neither? And so you want to decide, okay, you can make it however you want to. I'm going to make two triangles with similar 90-degree angle, two acute angles, and I'm going to make a second triangle, kind of making it the same shape, again with a 90-degree angle. And I'm going to say that my drawings, now you can make yours congruent if you want to, or neither, but you have to label it. But my two drawings, they are meant to be exact the same shape, but they are different sizes. So in this case, mine are similar. Number 19, we have two triangles. Triangle XYZ is similar to triangle ABC. And we want to list the corresponding parts. So what you're going to do is draw two triangles. I'm going to draw two. This one here, I'm going to use these same triangles actually, and I'm going to, these are similar, same size, same shape but different sizes, and I'm going to label this A, B, C, and then, oh I'm sorry, they have it, X, yeah, there we go, and then we have X, Y, and Z. So those are my two triangles that are similar. And so now I'm going to list the corresponding parts, the parts that match up. So I'm going to say that angle B, because it's 90 degrees, corresponds to angle Y. And now we've done this before, so now take a look. What are the other angles that would be corresponding or matching? If you said angle A and angle X, you are correct. If you said angle C and angle Z, you are correct. Now we want to match up the line segments of these corresponding sides and corresponding. We did the angles, so now we're going to do the sides. So we're going to match up, in this case, line segment. I'm going to go line segment AB matches up with line segment XY. I'm going from an acute angle to my right angle. And then I'm going to take a look at this side, and I'm going to go from line segment AC to line segment XZ, and they match up. The base of these two triangles, if I take a look, line segment BC matches up with line segment YZ, and the order has to match up as well. So corresponding angles, corresponding line sides. That's number 19. Number 20. The question is, if two figures are congruent, are they also similar? So if I have two shapes that are congruent, same size, same shape, are they also similar? Yes, technically, yes they are. So yes to the first question. And number 20, are they also similar? In this case, they are congruent figures always have the same size and shape, same shape, so they're also similar. So, but they can be, in this case, both of these are similar and they are congruent. Now, if they were different, if you had two similar triangles, are they similar? Yes. Are they congruent? No. So congruent triangles can be similar and congruent, but similar triangles can only be similar. Let's go to number 21. Number 21. 21, are all squares similar and all rectangles similar? Well, if a square can they all be similar? No matter how big or small we make them, as long as they're similar. They all have to have the same. They have to have equal sides and 4 equal angles. And so are all squares similar? In this case, doesn't matter how big you make them, but yes, all squares are similar. Are all rectangles similar? Well, we can have a rectangle that looks like this, and we can have a rectangle that looks like this. So those are kind of similar, but we could also have a rectangle that looks like this. And so rectangles can be lots of different lengths and widths and that kind of thing. So rectangles, no, all, rectangles are not similar. And that's number 21. Number 22, you're buying a CD and you have that teaches you how to speak Spanish that costs $28.75, and there's 6% sales tax, and you have $30. You want to know if you have enough money to buy the CD. So, question is, do you have enough money? To buy a CD? Do you have enough money? And you have $30. And the tape costs $28.75, and then 6% tax. There's a little bit of tax on there, so you're pretty close, but we have to figure this out. So we want to know, what is 6% of $28.75? And then we want to make sure we add that tax on. So 6% of $28.75, so we want to multiply 6%, which is 0.06, and if you multiply that out, you're going to get 30. We can do the regrouping thing. 42, 41, 42, 43, and 48, 49, 50, 51, 52. And then 6 times 2 is 12, 30, 40, 50, 60, 17. So you get, and then we have to move the decimal 1, 2, 3, 4. 1, 2, 3, 4 places. So we end up where it is going to tax us and be $1.72 if you round it. So we take our $28.75 and we add on $1.72 for tax, and we find out that we have 7. The cost is going to be $30.47. So no, we do not have enough money. Okay, and you have to show your work on that one. Number 23, you are using a protractor and drawing an angle with a measurement of 55 degrees. So take your protractor, draw a ray, and then make this your end point. And then we want to measure up 55 degrees, put it on the outside, 55 degrees, and then draw the second ray that connects those two, and label it 55 degrees. 24 and 25. We want to find the product and the quotient. So we have about a minute here left, and then I'll let you go. So your number 24, you have 3.25 times 5.6, and you're going to multiply that out. You can go 3.25 times 50 and 3.25 times 6, and then add those two parts together, and then move decimal at the end. So in this case, 3.25 times 50 is equal to 1625, and if we have 3.25 times 6, you get 1950, and then we want to add those two parts together. So 1950, and then move the decimal 1, 2, 3.